we're staying until 3:10 now?
What? No, they're not changing the hours of the
Is
day
it that
again.
we all collectively failed the quiz?
No.
Oh, I forgot we even had a
We didn't collectively. We might have individually, but not collectively. Zach, Sam, no Kevin. All right. Jules,
We don't have
Aiden.
Friday off anymore.
Ooh, that would be terrible. Well, no, that wouldn't be terrible. I got to be here either way, so it doesn't bother me if you guys don't have Friday off.
Is Mr. Brand not going to be here at all this week or the rest of the week? That would be good news.
What?
For you and me, but no.
What day is it?
Today is the 30th, the last day of September.
No.
All right. Okay, so on Friday you took your quiz, ladies and gentlemen. And I know you took your quiz because I saw you take your quiz.
Oh,
Did
wait.
you lose them?
I didn't.
Canvas did?
They never came to me.
Oh my
So we all passed. Please
No,
don't
so we
make
have to
me
retake
again.
it.
No, please don't make me take it.
Are you making us retake it?
I haven't decided yet.
Please
I don't want to retake
It would be the exact same quiz.
Okay, and
I don't
You
remember
should-
what I said.
What? You don't have to remember what you said. You know the questions now.
I don't know. What if I don't have them memorized
So
anymore?
here's the weird thing. Your class didn't come through.
But everybody else
My
did?
second hour didn't come through.
Oh.
So then I'm like, I don't even know why I'm giving it to third hour. Their results came through.
Oh, hello.
Now I can go online and I can see that you guys took it because it puts a mark by your name. But it didn't grade the ones that it could grade for you, and it doesn't show me that any of you answered any of the ones that were where you had to type in your answer.
Okay.
So
Hear it.
So I'm debating on what to do, ladies and gentlemen, and more than likely what I will say is I'm more than likely going to just say, well, I'm going to skip it for you guys. You'll have one less quiz than my other classes. So
But then you should make
that's
it-
yes, and that's good and that's bad, but you don't get the feedback to know how you're doing for this material that's going to be on the test.
Yeah.
So it is what it is, ladies and gentlemen. So I thought about just making you come in and retake it right away this morning, but I thought, ooh, that'd be a cruel thing to do on a Monday morning. And I really was going to do it, but then my wife was like, no, you really shouldn't do that. So,
Not really. That's pretty on brand for you, Mr. Brand.
so you're
No,
saying
it's
we
not.
should do it, Jules?
Mr. Brown would
Yeah.
never
You're
do
saying
it
we
on
should
Monday.
do it. You want to just do it and get it out of the way right away right now.
No.
Okay, you guys can all find Jules after school out in front by the flagpole, and
No, you're not gonna find me outside.
you're staying in school all day?
Pretty much, actually.
You got
Okay.
a musical?
Yeah.
Okay, you'll find her in musical practice where at some point she will have to leave and then you can meet her outside and take care of her. So, okay. All right, let's do what we were going to do though today. Today we're going to finish up atomic structure, and then I've got a short lab activity that you're going to do in the back, getting us ready for what we're going to start talking about tomorrow. So, just a reminder. You need to get a retake done if you want to do it. You need to get missing things turned in. Why? What the heck is hoisted? They've opened the grade window, which means I can put grades into the computer anytime now. I have until next week, Thursday at 7 a.m. to do so, ladies and gentlemen. What that means is if you are missing something and you don't get it done by the end of this week, it will not be on your grade for the first grading period. Okay?
Your quiz is still open.
I know, I opened it again this morning trying to see if maybe you could go back in and you could, I even set it for 2 attempts but when you try to log into it, it just says you've already finished it. I was hoping maybe you could go back into it, change an answer or something, and maybe it would come through to me. But the student that I had try it this morning, it didn't work for them anyway. I've tried everything that I can think of, and I don't know. Anyway, ladies and gentlemen, again, if you're missing a quiz, if you're missing a lab, if you're missing the first test, you need to get it made up, okay? Because if you don't, it's going to go in as a 0. And I guarantee you, if you're missing things, the chances are your grade is going to be much lower, if not failing, okay? So again, get the things done, get them made up. If you want to start looking at a retake, you need to let me know when you're going to do it and get things going on that, because again, we don't have a whole heck of a lot of time, ladies and gentlemen, until our next test. So please keep that in mind, okay? On Friday, we talked about atomic structure. Tell me something about atomic structure. Finley, tell me something about atomic structure. Anything about atomic structure.
There are protons, electrons, and neutrons.
That's 3 things, Finley. Slow down.
Protons.
Okay, we'll take that. There are protons. Good. Good. Evelyn, tell me something. What? There are neutrons. Okay, we'll go with taking and running off of the coattails of Finley. All right, Albert, what do you got? Tell me something about a proton then. They have a positive charge. Good, 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 good. So, okay, I'm going to save you the effort here, ladies and gentlemen. There are protons, neutrons, and electrons. We've got that much covered. All right, protons have a positive charge. Elsa, tell me something about atomic structure. Anything. Electrons have a negative charge. Alicio. Neutrons have a neutral charge, which really means they have what kind of charge? No charge. Neutral means no. And yes, we can use neutral, but what it really means is there's no charge to it. All right, go, 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 go. Stephanie. You look shocked, like, oh my God, he called on me. Why did he call him? Because there's so many more things to say.
Electrons have a negative charge.
Electrons have a negative charge. All right, good, good, good. We've got those charges things out of the way. Go ahead, Abby.
Protons are in the nucleus.
Protons are in the nucleus. Good. Let's move along there. Go for it. Adriana, come on. You got it. You got it. You got it. You got it. Come on. You don't know anything. I find that impossible to believe. What's your birthday? Then you know something. Don't tell me you don't know anything. Tell me something about protons, neutrons, and electrons. What's that? Well, what are you going to do on the next quiz? You're going to fail it. Well, that's a positive attitude. At least you're sure of something. Shining, help her out. Give me something. What? What are? Okay, atoms are really small. Kevin, go. We got a double Wait. Feel one more coming.
You're not allowed.
Doesn't count. You're a different person.
I wasn't prepared with the slideshow.
Jeez, Luis. I gave you a whole bunch of notes. There's all kinds that you can look at in your computer. And you can't tell me anything about protons, neutrons, and electrons that you learned in the 7th grade. Yes.
I was like forever.
Shh. Electrons are in the electron cloud. Kevin, I'm coming back to you.
Different atoms can have the same number of electrons.
Different atoms can have the same number of electrons. Karina.
Electrons are outside
Electrons are outside the
the nucleus.
nucleus. Good, because that's where the electron cloud is. Yes, yes. Jules. Jules, tell me how many grains of sand there are in the desert. No, let's go with the question of tell me something about atomic structure.
I don't know. They're really tiny.
They're really
You
tiny.
can't see them.
You can't see them.
Like atoms, you can't see them.
Yeah, but somebody already said that. Shiny ditch. You should have been listening.
Okay, they're microscopic.
That means they're very little, like Shiny said. Give me something else.
Mr. Brand. They're in everything.
Okay, I'll take that, Adams, and everything. Good, good, good. Itzel? Just pick one.
Are all the same types of
Adams.
atoms have the same number of photons?
Okay, run that by me again, because I want to make sure that what I heard is what you said.
Like the protons, like all the same types of
Okay.
atoms.
All the same type of atoms have the same number of protons. Yes, that is true. Okay? That is because the protons give an atom its what, Giselle? Protons give an atom its what? Good. But electrons steal. Tell what about the atom? He's now quickly moving to that page in his notes.
Okay, let's start again.
Electrons describe an atom's what?
Chemical reactivity.
Chemical reactivity. Okay? So the protons tell us what kind of atom it is. The electrons tell us what kind of reactivity it has, ladies and gentlemen. Okay? Did we get through neutrons with you on Friday? You don't know? Okay, then let's pick up there, ladies and gentlemen. Let's pick up there with neutrons. Okay? So copy this down, ladies and gentlemen. Copy this down. I just asked, and you're like, oh, now all of a sudden you're like, yeah, we did that. So you've got this? Good. Then what do neutrons do for an atom? What do neutrons do for an atom, Ray? Protons give it its identity. Electrons give it its reactivity. What do neutrons do?
Can give atoms special properties.
Such as?
Radioactivity.
Very good. Radioactivity. It's almost like it was written in the stars for him, ladies and gentlemen. Almost like it was written in the stars for him. Two different atoms can have the same number of electrons. Matter of fact, when atoms gain or lose electrons, they gain to have a certain amount. A lot of atoms will have the same number of electrons. Two different atoms could have the same number of neutrons in their nucleus. But two different atoms cannot have the same number of protons. Because if you have different number of protons, you are different elements, ladies and gentlemen. And if you have the same number of protons, you are one kind of atom. Questions? Wonderful, wonderful, wonderful. Now, ladies and gentlemen, do you think I go over this stuff just because I need something to talk about for 71 minutes a day? You're wrong in that case, Kevin. You're wrong. I have lots of things I could talk about for 71 minutes a day. Okay? I could fill you in on my home life with my wife and 2 kids, but you don't want to be bored for 71 minutes a day. So I don't do that to you. Point being, ladies and gentlemen, I'm telling you this stuff because this is the stuff that we need to know. This is the stuff that matters about matter, which is what chemistry is about. Got that? Good. I'm glad you caught that, Jules. Awesome. Excellent. Wonderful. Okay. So, couple key vocabulary terms, ladies and gentlemen. There is what is called an ion and there is what is called an isotope. Who can tell me what an ion is? No, it's not a car by Saturn, because you guys are probably too young to even remember that Saturn used to be a car company, let alone that they made an ion. So what's an ion in chemistry? You okay, Jules? You gonna make it? No? Okay. Nobody? Nobody remembers what an ion was? I would probably have to call on somebody who I had when they were a freshman, that I could call on, that I would know they would know this answer, because I know I taught this to them when they were a freshman. Who could I do that to? Who did I have in my freshman class that I could do that to?
I think you had Karina.
Karina, did I have you when you were a freshman? Jules, did I have you when you were a freshman? Really, Jules? Because you're very memorable. You're the kind of student that teachers don't forget.
I don't think you did. A charged particle atom that has gained or lost electrons.
Wow, look at that. She remembered, ladies and gentlemen. An ion is a charged particle. An atom that has gained or lost electrons. That is the only way an atom can become charged, ladies and gentlemen, is if you gain or lose electrons. You cannot gain or lose protons. Why? Abby, you are talking to your computer.
It always wants to update when I have your class. It doesn't want me to put these notes in.
Well, maybe you should update it some other time.
You know what? It doesn't give me the option until right this second.
Right this second.
Yes.
Every day this second.
Yes. You just don't understand. the
I
gravity
don't.
of
There's a
it.
lot of things I don't understand.
You know that.
Yeah. Understand better.
Understand better. That's
Why can't an atom gain or lose protons?
Because matter can't be destroyed. I don't know.
It's not about destroying it, though. Literally, the electron, some atoms will try to give away electrons. Other atoms will try to gain electrons. That's how come they can become charged. Some atoms want to lose electrons, some atoms want to gain them. And it's not destroying the atom when it does that, ladies and gentlemen. It actually is making the atom more stable. But why can't we gain or lose protons? Two reasons. Come on, think about it. Why can't we gain or lose protons? It changes the atom's identity. So you were a carbon atom, you gave away a proton, you now become boron. You change what you are. Atoms don't do that. That's called a nuclear reaction, not a chemical one. In a nuclear reaction, atoms can gain and lose protons. Those are very specialized. We will only talk about them a little bit in here, not much. What? I called him a boron. Boron. Okay? I would never do that to an element. Maybe a student, but not an element. Jules, you're not a boron. Don't worry. Okay? All right. Now, the other reason you cannot gain or lose protons, but you can gain or lose electrons, has to do with one of the three ways that protons, neutrons, and electrons are different from each other. No, not charge. Because you can lose a positive charge as easy as you can lose a negative charge. That doesn't matter. Think about the other two things. Which one do you think affects why an atom can easily gain or lose electrons but not protons? If I were you, I'd be looking at the slide that has proton, neutron, and electron. It has location, it has mass, it has charge. And tell me why we cannot gain or lose protons. Good, that's a positive start to the morning. Why can't we gain or lose protons? Good! That's a good way to start the sentence, because I limited it down to a chart with three things, and we've already eliminated one, which is charge.
This is the mass.
You got a 50-50 chance. What?
The mass?
No.
The location.
What about the location?
Well, because proton and neutron are in the nucleus.
Okay.
But the electron is in the electron cloud.
Which is where?
Outside.
Outside of the nucleus. So if you think about it, the first part of an atom to touch another atom will be the what? What? No. Not the nucleus. The electron cloud.
Yes.
So atoms can easily gain or lose electrons from the electron cloud because it's outside of the nucleus. It's the first thing that another atom would touch. So if an atom wants to lose an electron and it runs into an atom that wants to gain an electron, well, those are the parts of the atom that are touching, the electron part. So those are the parts that can do that, ladies and gentlemen. Okay? By the way, when we talk about an ion, we have to write a positive or negative sign, and we have to write a number with it. Now, the charges are normally like +1, +2, +3, +4, -1, -2, -3, -4. There are a few weird atoms that could get up to as much as a +7. But we have to indicate that by after the symbol putting is a superscript, meaning up above, a plus sign, and a number. By the way, do you know how to make a superscript on your computer? You hit the control and the period key at the same time, and you will now type in superscript mode. If you hit that again, it will take you out of superscript mode. Control and comma, by the way, will get you into a subscript mode when we are writing formulas later on.
Little baby numbers.
Little baby numbers in the upper corner, isn't it cute? What, Jules?
How do you do it?
Control, period, at the same time. I'm sorry, Kim, what was that?
Oh my god.
It's +2. +2 for sodium, -2 for oxygen, -1 for chlorine.
Keeps going away. I'm like, this. All this working for what?
Well, it'll only stay in that area. If you move to a different area of your screen, it'll go back to whatever formatting is in that area.
Yeah, well, tons of Oh.
You tell it to not. Thank you. By the way, you could also type in the +2, highlight it, and then hit Control and the comma key, and that would make it a Control and the period key. That would make it a subscript as well.
How do you have all this knowledge?
Because when you have to use this stuff so much, you get to learn
He's
things.
old.
How do those people who check out groceries when I bring my apples up know the code for Golden Delicious apples? I don't know. But I think because they use it often enough, they learn it. So that would be my guess.
Dude, the way, why even ring up the apples correctly? Who's gonna call you out?
I am. You charge me too much for my apples. I'm gonna have a.
No,
We're
I
gonna
gotta
fight
just-
right then and
I
there.
gotta grab some golden apple crisps, and I'm paying for the cheapest apple in my self checkout.
You cheat the system. You steal. Abby is a stealer, ladies and gentlemen. She steals money from the grocery store, which causes all the rest of us to pay a higher amount of money when we go there. Why? Because of people like Abby, who won her apples for 98 cents instead of $1.09 a pound. That dime, I hope you sleep well at night for
I
it.
sleep amazingly with my great apple crisp.
Oh, actually, what you say is I sleep wonderfully on a sleep number bed. Haven't you seen those ads? Okay, so what is an isotope, ladies and gentlemen? Those are atoms that have the same number of protons, but they have different numbers of neutrons in their nucleus. They have different numbers of neutrons in their nucleus. So that makes these atoms slightly different from one another. Now, they're still all the same type of atom, but not every carbon atom behaves exactly the same. Some have special properties. So there are three major types of carbon. There is carbon-12. It has 6 protons in its nucleus. It has 6 neutrons in its nucleus, and its mass number is 12 because we add the protons and neutrons together to get the mass number. By the way, why don't we add electrons into mass number? Ooh, go ahead, Horshack. She has no clue who that is.
No, I don't.
Do any of you have any clue who Horshack is?
No.
Okay, you'll have to look up Welcome Back, Kotter and watch it. Okay, go ahead. Jules, go ahead.
What?
I was assuming you were going to answer the question because you were like, ooh. Why don't we add electrons into the mass number, ladies and gentlemen? Oh my gosh, you might have to think back to that chart that we've had to think back to once today.
What chart? The one of the atoms of this stuff?
That might be the chart we're talking about.
Wait, what are you asking about?
Why do we not include electrons in the mass number of an atom?
Because it's like what?
Nope, not to deal with charge.
Well, because looking back on what you told us to write down, it says 1-1876 A.
That's not a dash. That better not be a dash.
Well,
That better be a
whatever.
division sign.
That, yeah. And that equals to 0. Because if
No,
you
no, no, no,
divide-
no, 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 no. 1,876 does not equal 0.
No, divided
It's
by what?
approximately.
Approximately.
That's why the equal sign has a little line over the top, that squiggly line.
Approximately 0.
Correct. So
Because you.
why
divide
don't we
it-
include electrons into a mass number?
Because if you divide it by itself.
Someone help me. So I know it's Monday. I know it's been a long weekend. I know it's homecoming. I know you had a good time, whatever. Okay, we need to focus a little bit. Why don't they include electrons in mass number? Jules, you are literally standing on the edge. Just take the jump.
What did I even say?
Exactly. See, that's the thing. You don't even listen to yourself. Come on, someone help her out. Again, if it kills you, you will never have to answer another question in my class again if you're wrong. And you die from it. Come on. Why don't they include electrons in mass number? Because they don't really have any mass. Why would you include something where the mass is 0 into something where we're adding the masses up? Thank you, Elsa. Thank you. By the way, second type of carbon, carbon-13. Carbon-13 still has 6 protons. Why does carbon-13 have to have 6 protons?
Oh, wait, yes, I know.
Horseshack. Go ahead, sorry.
Because that one has 6,
Yeah.
and then that one has 7, and 6 plus 7 equals 13.
You are awesome, but that wasn't my question. You're absolutely correct, though.
Well, but you asked.
My question was, why does this carbon-13 have to have 6 protons?
Because they all have 6 protons.
Why? Because otherwise it wouldn't be carbon if it didn't have 6 protons. Very good. Now we're starting to make connections. So the only way carbon-13 can have a mass number of 13 is if it has 7 neutrons, because it has to have 6 protons. And then we have what is called carbon-14, ladies and gentlemen. Carbon-14, there are 6 protons, there are 8 neutrons for a mass of 14, a mass number of 14. Now this is the special one. Anybody know what's special about carbon-13? Carbon-13 is radioactive, ladies and gentlemen. Matter of fact, that's how they date how old artifacts are when they dig them out of the ground and they see how long they've been buried there. It takes carbon-13 about 5,760 years for half of the carbon-13 in an object to decay away. 5,760 years. So they can go back and figure out how old something is by how much carbon-13 is left in it. It's called carbon dating or radioactive dating. And it's a special property because it's an isotope, because it has a different number of neutrons than most carbon do. Questions? Good! So now I am a charged atom, ladies and gentlemen. I do that special. That's the freak out Halloween feature of this, where it kind of blinks and things like that. Atom, neutral, if the number of protons is equal to the number of electrons. All atoms start out this way. All atoms don't stay that way. Ions are created by gaining or losing electrons. Gaining or losing electrons. What? Type. I don't know. What do you want to type?
Mr. Byrne, why'd you become a science teacher?
Because I couldn't figure out what a derivative was.
What's that?
Math.
6 weeks into calculus, I had no idea what a derivative was. I decided to become a science teacher.
That is so real. But we said I would decide to drop out. Goodbye.
Nope, I was already committed. I had already,
You already paid for it?
correct.
Yeah.
So it was either math or science. I got to calculus, got to derivatives. By the way, there is no such thing as a derivative in calculus, ladies and gentlemen. Anybody know what it actually is called?
No.
It's called a derivative. But when you have a teacher who has a really bad accent and you're looking up derivative in the book, you will not find it. So it took me a long time to figure out what the teacher was saying, and by that time I'm like, you know what, science really isn't that bad because I still get to do math. Okay, if you gain electrons, ladies and gentlemen, you will have a negative charge. If you gain electrons, you will have a negative charge. Now, this is a weird thing because normally when we think of gaining things, that's a good thing, right? Okay, but it's not. You're gaining negative charges here. So you start out neutral, you gain electrons, you have more electrons than protons, you have a negative charge. The only way you can gain electrons, though, ladies and gentlemen, is if some other atom will lose electrons and then they will have a positive charge. Okay? This is the only two ways you can become charged. And most atoms on the periodic table will become charged. All but 7 of them. Those are the 7 right there. Group 18. Those will never become charged. We will explain why later. Questions? Good. By the way, if you have a negative charge, we call that being an anion. An ion is having a charge. An anion is having a negative charge. And a cation is having a positive charge. Now, if you had me, if you had Miss Polkowski, if you had Miss Schunard, if you had, who else could you have possibly had for physical science? Anyway, if you had one of us, it was never my idea, but they taught this way. Cation, they would draw a picture of a nice cat face, and they would make pluses in the eyes for positive. Anion, they told you to think about an onion because it would make you cry, which was a negative thing apparently. I don't know. You got to remember that an anion is positive and a cation is negative. Sorry, flip that around. An anion is negative and a cation is positive. Sorry. Questions?
Is the second one spelled correctly?
No, it isn't. Take out that I after the T. No, take out the I after the O. Cation. Sorry. Sorry. Well, here, let me fix that right away because that's bad. There we go. Not a problem. Perfect. There you go. What spelling here? Good. Questions? Charged atom. Take the number of protons minus the number of electrons. Take the number of protons minus the number of electrons. That will tell you the charge of an atom. Be it positive or negative. Now think about this. If this number is larger and we're subtracting by a larger number, what do we get? We get a negative number. So we would get a negative charge. Okay? You have more protons, you're going to get a positive charge. Questions? No. Wonderful. Awesome. Excellent. Incredible, ladies and gentlemen. Good. Let's get to properties and changes, but not now. Instead, ladies and gentlemen, go into Canvas and open up the aluminum and copper chloride lab. Aluminium and copper chloride lab, ladies and gentlemen. When you open it up, it looks like this. It looks like this. It looks like, excuse me. This, ladies and gentlemen.
We don't got it.
Huh?
And I don't got it. Hold on, it might be up here. Nope. Okay, well.
Heh. Hold on. Hold on. Don't. Okay. There it is for you, ladies and gentlemen. Correct? Refresh. Got it? Refresh. There it is at the bottom of the. Is it there now? Woohoo! All right, there we go. So today we will determine if the steps of a lab represent a physical or a chemical change, and we will provide reasoning to support our decision. So, what's the difference between a physical and a chemical change?
Something that you can physically do is physical, and something that you have to do with like chemicals is chemical.
No. Nice try, but no. Seriously, come on, somebody help me. You guys have all learned this. What's the difference between a physical and a chemical change?
Physically, you can control. They actually are. You can control both.
Correct.
You can control how much chemicals you put, how much stuff you put into.
All those things you're saying is absolutely correct, Joe. So give me the difference between a physical change and a chemical one. By the way, think back to your definition of a compound. Two or more elements combined how? Okay, which one was it?
I think it was.
Physically, it was a mixture.
It's chemical.
Chemically, it was a compound. And what was the difference between physically combined and chemically combined? They were fused. They were put together, right? A mixture, they just happen to be
In the same area.
in the same area. So what do you think the difference between a chemical and a physical change is?
The way that they.
Things like force together.
Okay.
Chemicals just
They become one day.
Okay, you're very close. They become something new,
oh yeah.
something different. Physical, you may change how it looks, but you don't change what is there. So, for example, what happens if you throw salt into water?
It's salty.
So
You get salt water. But what actually happens to the salt when it goes in the water?
it dissolves.
It dissolves. What does that mean?
So
It would be unpleasant to drink.
Why?
It's salty.
Okay. Is it something different though?
no,
I mean,
It's just salt and water, right? What happens to the salt though? You said it dissolves. What does that mean?
and it gets mixed with the water.
Get mixed with the water, but does it actually change the water? Does it change the salt? So what kind of change is that? Physical or chemical? That is a physical change. When you dissolve something, that is a physical change. Why? I want the salt back. What do I do? Nope, too small. But you're close. I boil off the water. I boil off the water. The water will be up in the air. The salt will be left behind. And I will get the same salt I had before I ever began the experiment. The same salt I have, I will get back. You know why? Because I didn't change the salt.
she'll never get the water back.
Sure I could.
That's not very happy.
I could run it through a distillation column,
So
which would take the steam, cool it down, and then I could collect the water in a different container.
a different kind of filter.
Well, a different kind of separation. But the key is I can do that because it was only a physical change. All I did was have the salt dissolve in the water. Okay? But if two things come together and you change what is there, then you get a chemical change. You are going to look at a lab today and you are going to determine if chemical or physical changes happen. So here's what is going to happen, ladies and gentlemen. At your station, there is an empty beaker like this. At your station, there is a weighing boat with a blue powdered substance in it like this. And at your station, there is a piece of aluminum foil at it that looks like this. Now, the first thing you are going to do is you're going to put 25 to 30, and this is approximately, which means the markings on the side of this are good enough for this. 25 to 30 milliliters of water. And now I'm going to make 3 observations of each and every one of these 3 things. 3 observations of the copper chloride, 3 observations of the water, 3 observations of the aluminum foil. You could touch each, you could smell each, you can look at each, do not taste each.
Why?
Because copper chloride is poisonous, slightly toxic. I don't want to know how slight you are. Okay? You will put 3 observations here. Okay? 3 observations here for each of these things. If you don't, you're not getting your points for this. 2 points for each column for your 3 observations. 4 would be better because I had somebody who literally for the last line put down, the object is clear, the object is clear, the object is clear, the object is clear. Thank you for repeating the same thing 4 times. That's 1 observation, not 4. Okay? You already have 2 to 3 grams of copper chloride in the weighing boat that is out at your station. After you make observations of both the water, the copper chloride, and later on you're going to have to make observations of the aluminum foil. If you want to do it right away, you can. You are going to take and add the copper 2 chloride to the water and swirl the chemicals together in the beaker. So you're going to take, put them together, swirl this up. Now, this is your first chance to determine if you have made a physical or a chemical change when you put these 2 together. So, you're going to want to write down things that you see happen so you can identify eventually whether this was a chemical change or a physical change. So, adding the water to the copper chloride in here, you're going to write down some observations. What did you see happen? Questions? Okay. Step number 4, after you get a small piece of aluminum foil and make observations of it, you are going to take and loosely roll the aluminum foil into a stirring stick, something like this. Do not take and twist this all up and make this into the thinnest piece of aluminum foil you can. You want to loosely roll it. Now, did I change this? Did I change this? It ain't the same shape it was before, is it? Okay, so when you're rolling the aluminum foil, write some observations. Minimum of 3 if you want credit. You don't write 3, you don't get credit. 3 observations, because then you're going to have to determine if this step was a physical or a chemical change. Then, ladies and gentlemen, you are going to take and you are going to stir the copper chloride solution with the aluminum foil for about 5 minutes. You're going to stir it up for about 5 minutes. And you are going to record what happens during that 5 minutes. And then you can leave this sit in that container for a few minutes. And again, record any observations that you see happening down here. And you are eventually going to determine if that step was a chemical or a physical change. Now, very important, ladies and gentlemen. Evelyn, Jules, listen carefully. Evelyn, Jules, head up. This cannot go down the drain. There is a container in the middle section, in the back, a glass jar. You will take this and put it in there, and then you will swirl this around to get all of the solid stuff that may be at the bottom in here, and you will dump it quickly into that container. Now, when you do, some of the stuff that's in here may or may not stay behind. It all depends on how quickly you dump it. And by quickly, ladies and gentlemen, that means fast. That doesn't mean that ain't going to cut it. Swirl it around, dump it fast. If there is still stuff left in here, you take this wash down bottle. You add a little bit of water, swirl it around, and dump it again. You take this to your sink, you wash it with soap and water, you dry it with a towel, you leave it laying on your station. The white weighing boat that is now empty, you throw away. The aluminum foil ends up in there. You will leave this sitting at your desk. I will set everything up for the next class. Are there any questions? The final thing you need to do for this lab is write a conclusion. In your conclusion, you are going to tell me during steps 3, 5, and 6 which changes were chemical changes, which changes were physical changes and why you think they were either chemical or physical. What happened during the lab that makes you believe this change was physical, or what happened during the lab that makes you believe this change was chemical? Questions? So there are 20 of you. That is 10 groups of 2. At a lab station, 2 people on each side. You're working with the person who is on your side. Nobody works alone, ladies and gentlemen. If you can't figure that out, I will put people together to figure that out. So either find someone who you like to work with, or you're leaving it up to me to assign the 2 people who are alone at the end to work together. Let's go.
Your charger was overheating, by the way.
Overheating? Did it charge?
Yeah, it did, but I unplugged it after a while because it was overheating.
What?
I don't know if it was.
No, it wasn't
stuff
me. Kelly
we
had
had.
it. Kelly had it.
Oh, I just
You're
assume
off the hook.
it's always me.
No, don't assume it's
I
always
just
you.
remembered from Guyak I had some, but I thought it was from
What
the
are you
last
using
time.
for Guyak?
Yeah, we used for heating.
Oh, that's right. Okay, yep, that's right. Sorry. Nope, you didn't have it. You're good. You're good. Use the water out of the pitchers. It will be a lot faster to fill 25 milliliters than trying to squirt it out of your squirt bottle for washing things down. Or you could keep doing it with those squirt bottles instead of using the pitcher. I guess that choice is yours if you want to take a lot longer rather than listening to the person who has experience with such things. I'm just trying to make it go quicker for you. If it's the same water in either one. $25 to $30 approximately. By the way, if you touch my brother, no problem with that. You can wash your hands when you're done at the end. No water, you can touch it. They're so old. Find it. Where are you? By the way, Wayne's all good. All good. Yes. Make sure your white inches get thrown away after you have taken the copper chloride out of them. Moving, ladies and gentlemen, you have exactly 15 minutes left in class. Just saying. When you're done, you can take a sheet. You didn't have to. Yes. Whenever my rule of observation is you should always do three. It's in three. So three things that happen when you're rolling the foot. Three things that happen. Now you may want to write more, because maybe more happen, but you have to write at least three. Stop. Wash out. Add some water. You were done with the lip. Yeah. 10 minutes, ladies and gentlemen. 10 minutes till class is over. Please make sure that you wash your container, you dry it. So the next class starts out with a dry container. Right, Jules? And Gianna, clean up your station a little bit and dry your reader, please. Don't quickly, absolutely okay. Roll it around and then drop it. A little bit there. That's not anything. You did a good job. Leave the major where there is the line for the next group of days. Generally, you need the dollar. Remember, I don't want to say spelling errors in the same spot.
I'm gonna make all the spelling errors intentionally just to stress it out with the rest.
Okay, then I'm gonna do it. I don't want to stress it out. Hey, I just get through it.
Not you. Okay.
Well, that has to be open. Okay. Well, let me ask you this. Do you think you can yourself as a sometimes people think this. Right, right. Still need to do your conclusion, ladies and gentlemen. Your conclusion focuses on steps 3, 5, and 6. Well, here's the thing. If you use the powder substance, I will understand what you mean. Okay, but there's nothing wrong with using, the copper chloride or however you want it. You can write the formula, you can talk about the powdered substance, you can write the name. I don't care which. All of these things. Here's how I was started. In step number 3, this was a blank change. Here's why. In step 5, this was a blank change. Here's why. And in step 6, it was a blank change. And here's why. That's what you're filling. What kind of change it was and why you think it was that change. Well, have your partner read it and ask her if it makes sense. Yes.
Would you agree that these steps are these are-
Well, I'm not going to tell you that because it's based off of what you think.
Like, okay, so you're saying in step 3, I would think that
That looks very good. Now, I will tell you this. You can be briefer. You don't have to worry. You don't have to try to make this very long. But what you've done is fine. Okay? Right? In that paragraph and a half, I know. Okay? I'm expecting maybe 3 or 4 sentences. Okay? I think you expanded on things really well. I think you could shorten that, but there's nothing wrong with what you've done. Okay? Well, and here's the thing. Look at everything overall. Look at what happened during the lab. When do you think there was a chemical change compared to when was there just physical change?
I was just trying to figure out how to describe why I think it's not. Because I can't really describe why I feel it. So, I don't know how to describe why I think it's.
Okay, then how about saying some of the things that you think were a chemical change didn't happen? So if this was a great indicator that it was a chemical change, did that happen when you did these other steps? If not, you could use the reverse engineering of because this didn't happen, that probably means this was physical.
Well, you said because there were still some things that people mix a lot.
Okay. Okay. I didn't say that. I didn't say not enough. Give me a reasonable attempt to answer it.
Okay, I'll finish this by 3.
Remember, it's due tomorrow. Okay? It's due tomorrow. Look, due 10/1/24. That would be tomorrow, not today. Give you time. Give you time to think. Give you time to plan. Give you time to get it done. Thank you. Goodbye. Have a great day. Welcome to this week, ladies and gentlemen, where the week will only get better for you. You certainly may. Oh, you can't use my sulfur. You didn't ask about that, Andy.
Oh, I got it. I mean, I figured it came with the sink, you know?
No, it didn't. It's separate. That's why it's sitting on top.
You know how you think the furniture comes with the house before you
No,
buy
I
it?
never think that because every house I've ever looked at has been empty.
Well, why
Never.
would you do that?
Would you be available after school on Tuesday?
Yes.
Okay.
Yep, for a little while. Yep, till 3:45. You bet.
My goodness.
Garbage can over here.
I touch my face too much to take any risks. Let's be real.
Well, it's better safe than sorry. Let's be real there too. Hello, Kayana. How are you? You survived homecoming?
Actually went camping.
Did you?
Yeah.
Really cool.
The whole weekend.
Very cool. All right, I will be back in just a moment. Hold down the fort.